So Unit 5, we're not going to be solving many equations. So an equal sign, not going to be around, but we will be simplifying expressions, okay? So no longer equations, but simplifying, okay? We have 4 lessons. We are going to remind ourselves of all of the exponent properties today. We will be adding and multiplying different expressions with x's and things with exponents the next day. And then we finish off with 2 days of factoring. Question? Sure. Anybody else not get one? So, what is an exponent? Please put your book away, Ms. Williams. What's an exponent? Talk to your neighbors. What's an exponent? Good. It is a number indicating how many times you're going to multiply what we call the base number by. Okay? If I see 5 squared, why is it called 5 squared? Why isn't it just 5 to the second power? Why do they call it 5 squared? Nope, not because you square root it. Something about being a square.
It covers all of the grounds.
No. It's the fact that if you take a square of length 5 and you multiply it by 5, what do you get? What do you get when you take a square? You get 25, but what does that represent with the square? The area, okay? This is why they call 5 squared squared instead of 5 to the second power. It's because you're getting the area of a square with a length 5. Why do you think they call it cubed? If this is 2 cubed instead of 2 to the 4th. Why do you think they call it cubed? Why isn't it 2 to the 3rd power? Because of what? I heard it, the V word. Volume. Thank you, Mr. McCurley. Appreciate it. Because it's the volume of a cube, which has all the same sides, with a length 2. Okay? And that's just 2 times 2 times 2. Now, something to the 1st power means you're multiplying it by itself, but not 2 times. It's just itself 1 time, which is why something to the 1st power is just that number. Now, the next 2 are very important because I see many students, even seniors, mess up on -2 squared versus -2 in parentheses squared. Okay? The answer is different. The -2 squared in parentheses would be like -2 times -2. What's a negative times a negative? Positive. This is a positive 4. However, this is not a positive 4. Because order of operations says we need to square things, we need to use exponents before we do multiplication. This can be thought of as -1 times 2. And if I use the order of operations, this would be 2 squared, which is 4, times -1. This is -4. Okay? So that's how exponents deal with numbers. But exponents deal with variables. It's important to understand x squared is just x times x. This is how we're going to recall and remember the rules of these exponents. X to the 5th would be x multiplied by itself 5 times. Three times x squared times y to the 5th. 3 times x times y times y times y times y times y. Now x squared squared. Why don't we write this as x squared cubed? 2 ways you can do this. You can either say, okay, this is x squared 3 times. That's x squared times x squared times x squared. Or you can say this is x times x times x times x times x times x. How many x's do you have? 6. This ends up being x to the 6th. We'll go over that a little bit more. Okay, another way to do it is you could write it as x times x cubed, and then you'll have this times this times this. Okay, we can discover that this 2 gets multiplied by the 3 if you take a power to a power. This guy, we can write it as 3x squared y to the 5th times 3x squared y to the 5th. And we can go from there. If you think about writing things out, you can discover that if you have an x squared and an x squared, you get x to the 4th. Well, that doesn't, I don't know based on that if I added them or multiplied them. But let's look at y to the 5th. What's y to the 5th times y to the 5th? Discuss that with your neighbors. Is it y to the 25th or is it y to the 10th? Discuss. And if we are not sure if it's y to the 10th or y to the 25th, what can make me sure? That box. So, some of us are not sure. They're like, oh man, I feel like I need to take that 5 and multiply it by that 5 and make it 25. Because it's like, oh, 2 times 2 gets 4, so maybe 5 times 5 gets 25. But if I wrote it out, and I understand it's 3 times x times 1, 2, 3, 4, 5 y's, times 3 times x times 1, 2, 3, 4, 5 y's. How many y's are there? 10. There's only 10. There's not 25. So this is y to the 10th. So you can just figure out that we're actually adding our exponents when we are multiplying things. We have 4 x's and we have a 3 times 3, which is a 9. So if we take a power to a power, we end up multiplying. If we are multiplying, we end up adding. Okay, and we'll get there. We'll do more of those soon. Okay, but we're going to start with negative exponents. Now, negative exponents are tricky to understand what 3 to the negative 1st is, or 3 to the negative 2nd. But let's just kind of do a procedure here, and let's start with 3 cubed, then do 3 squared, then 3 to the 1st. So 3 cubed is 3 times 3 times 3. 9 times 3 is 27. 3 squared, 3 times 3, 9. 3 to the 1st is just 3 multiplied by itself just once. It's just a 1, 3. How do you get from 27 to 9? You divide by 3, okay? How do you get from 9 to 3? What do you think 3 to the 0 power is? 1, because when you divide this by 3, you get 1. What do you think 3 to the negative 1st is? 1/3, divide by 3 again. 3 to the negative 2nd, 1/9. Okay, this is our rule for negative exponents. First, the rule for 0 exponents. Anything to the 0 power is just 1. Just don't take 0 to the 0. That's confusing, and it depends on what you're looking at. It could be 0, it could be 1, it could be something else. Rule for negative exponents. Anything to a negative power is the same as 1 over that thing to the positive power. For example, if I have x to the negative second, I could rewrite this as 1 over x squared. However, if I have 1 over x to the negative third, that'd be like 1 over x to the negative third. That's the same as just x to the positive third over 1. Both of these are very important to understand. Okay, the rule for negatives with exponents, just remember, if you have a negative in front of something, order of operations says we need to square that thing first and then multiply by -1 to get -9. However, if we have the actual value -3 being squared, that's a positive 9. Okay? All right, let's start dealing with negative exponents. We want to get rid of all of the negative exponents. And 0 exponents, we want to simplify all of these. Well, x to the -4th. With your neighbors, confirm how you can get rid of that negative exponent. You just put it on top. And when you put it on top, what do you have to change? Makes the negative exponent positive. That's it. Now, -12, is that a negative exponent, the -12? No, that's just a negative value. So I'm not going to flip the 12 because it's not an exponent. I'm going to leave the 12, I'm going to leave the y, and I'm going to change the 3 to the -2nd to 3 squared in the numerator. If you want to make sure you have a denominator, go ahead, that's fine. Have a 1 down there. 3 squared is 9. You can multiply 9 by -12. Okay? It is important to understand when you have fractions or when you have multiplication or anything, you can multiply anything that you want in any order. I can say, okay, let's divide the A and D first, take the B, multiply it by the C, and put 1 over e to the f. I can separate things out. I can multiply things in any order. We don't have to worry about this being to the right and the -12 being the left and the y being in between. The -12 is not married to the y. It's -12 times y times 3 squared. What's 9 times 3 squared anyways? I mean, what's 12 times 9? 108. So this is -108y. The next one. Sometimes it's easy to just start with a fraction. Start with a line. If you have a negative exponent, move it. If you don't, leave it. So the 7 does not have a negative exponent. This is 7 times x to the -3rd, where some students make mistakes. Is they think, oh, it's 7x to the -3rd. That means the entire 7x cubed moves. Not true. The 7 does not have an exponent. It is not married to that x to the -3rd. If it had a parenthesis around the 7x, then you would move the entire 7x. But it doesn't. Order of operations says we're going to deal with the exponents first before we deal with the multiplication. So I would move the x to the -3rd, leave the 7. This is important. 7 stays. The 49 stays. 49 a to the 0 does not turn into 1. It's 49 times a to the 0. There's a dot in between there even though you don't see it. The a to the 0 becomes 1. The x to the negative third, that can be moved to be x to the positive third in the denominator. The y to the negative fifth can be moved to be y to the positive fifth in the numerator. Okay? And this would be how you would simplify this to get rid of the negative exponents. But there's more that I can do. Similar to what I showed you up here. If you have some stuff in fractions being multiplied, you can move things, divide anything that you want at any time as long as there's just multiplication. I can take this 7 and divide it by 49. That's 1 over 7. So I can make this a 1 y to the fifth over 7 x cubed. How do I turn this into a 1 over 7? I divide the top and bottom by 7. You're allowed to do that. You're not changing it. You're just making it look different. Okay? Do the next one.
So how do you get 7 over 49?
No. I'm just showing you that you can think about this being separate from things, and you can say that this is not married to the y to the fifth. This is not married to the x cubed. The 7 and the 49 can simplify each other. These seem easy, and a lot of us, I think, are like eye rolling, like, oh, this is Algebra 1. And yeah, I taught this in Algebra 1. But man, are these tricky. And students of all grade levels have difficulty with this. If I start with a fraction, I would leave the d cubed. I would move the x to the 10th, which means I need to have a 1 up there in the numerator.
Does it matter what order the x and b are in?
Nope, because multiplication says if I have a times b, that is the exact same as b times a. Multiplication is commutative, order does not matter. Okay? The next one, 2. X to the 0 does not all change to a 1. It's 2 times x to the 0 times y to the negative fourth. So 2 stays. X to the 0 turns into the 1. Y to the fourth moves to the denominator. Do the next one. Two stays, c to the fourth stays, 8 stays, d moves up to be d cubed in the numerator. So I have 2 c to the fourth d cubed over 8. Now, we can go further. Since this is all multiplication and division, we can divide the 2 by the 8 to make it a 1 over 4. So this is 1. We don't need the 1 because 1 times c to the fourth d cubed is just c to the fourth d cubed. And this turns into c to the fourth d cubed over 4. All right, let's keep going. Keep going. Get all the way to the end. Check your answers with the board. And notice 4 over 14 does not simplify to a 1 over something or a something over 1. But I can simplify 4 over 14. I divide the top and bottom by 2. It becomes 2 over 7.
Why didn't you do that? Like 2 over 8?
I did.
2 over 8. 1 over 4.
I did. I just should have drew those. Okay, 2 over 18. You can divide the top and bottom by 2. 2 divided by 2, 1. 18 divided by 2, 9. So I have a 1 here. It's just 1 times anything. It's just the anything. I'm sorry. Trying to get you going there. Yeah. Okay? Are there any questions about any of these? Let's please take our phones, put them in our backpacks or in our pockets, not on our desks. You guys are too tempted to use your phone, right? It's an addiction. Got to break the cycle. Right. Next page, multiplication. X to the 8th times x to the 4th. Now we can think, it's like, man, that's either going to be x to the 12th or x to the 32nd, right? I'm either going to add those or multiply them. Please discuss with your neighbors whether x to the 8th times x to the 4th is x to the 12th or x to the 32nd, and explain why it's the answer that you provide. We'll put this away. You need to focus. All the way away. This is not cool. Put this all the way away. Especially, come on, like after the test grade we just had, we can't afford it. What is it? Who's confident? What is it? X to the 12th. And why do you say it's x to the 12th and not x to the 32nd? Yeah, but that's just a rule that you learn. Can you give me another explanation that might like convince me? Because it sounds like you just memorized something, but
because
yeah,
you did x times x times x times x.
8 times, yep.
Times then x times x.
4 more times.
And then it would all add up to.
That's exactly what I'd like to hear. That type of conceptual understanding that if I have 8 x's, I don't even know how many x's there are here. That's 8. And then I multiply 4 more x's. Well, all of these are being multiplied together. How many x's are being multiplied? 12. Now, what if I have x to the 4th 8 times? This is the other one that we need to get to in this. Oh, so that's a rule, Mr. Pottorff. You're going to multiply the 8 and 4, but why? Go ahead, Mr. Pottorff. There's 4 x's 8 times. 4 x's 8 times is 32 total x's. So yes, this is why. And if we understand that, and not just have rules memorized that we can mess up on, but we have that kind of conceptual understanding as a backup, we should not mess up with these exponent rules. Okay? I like to say, when in doubt, write it out. You know, when in doubt, if you're not sure about the rule, just start by writing out a simple example, and then you will confirm the rule in your brain. Okay, so this, and this. We should be able to say 2 x's, 3 x's, 6 x's. That's 5 x's and 6 x's. That's 11 total x's that are being multiplied together. Now, what about x to the 4th, y to the 5th, x squared?
11x, or x 11.
I'm not sure, Mr. Manley, if that's the right answer. So you know what? Just to be sure, I'm going to go ahead and do this. 1, 2, 3, 4 x's. 1, 2, 3, 4, 5 y's, and 2 x's. That's a y. Okay. So 4 x's can be multiplied by 2 x's. I can move these 2 x's over to the right side. Anything multiplied together can be multiplied in any order. So these 2 x's can pop over here, which means I have 1, 2, 3, 4, 5, 6 x's, and the y's will just stay by themselves. Okay? Okay. Let's keep going. This means I have 2 y's and 4 y's. 6 y's. I can have it as y to the 6 times x or x times y to the 6. If I have numbers, numbers are the same. I have 3 3's, 4 3's. I have a total of 7 3's. I have 8 5's and then 2 5's. The total amount of 5's are 10. I don't have to break my calculator out for that. Now I have z's, y's, and x's. Write the next one. Now, if I remember my rule, I get z to the 7th, but all of a sudden I got this x and x cubed and a y to the 4th. There's no exponent here, there's no exponent there, so I'm confused. So what should I do? You can write it out. What else could you do?
Oh, no, it's just a 1.
There is a 1, a missing 1 from an x. X is the same as x to the 1st. Y is the same as y to the 1st. So this, now you can say 1x, 3 more x's. You can write it out to say x times x, 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 to know that you have 4 x's and 5 y's. Okay? Change this from x squared squared to x squared cubed so that we don't mess it up. Now, we are adding exponents here. Why? Because if you wrote it out, that's just how many you had. Here, we end up multiplying our exponents. That's the rule. However, the conceptual understanding is that we have x squared 3 times. 2 x's, 2 x's, 2 x's, 6 x's. That is why you can multiply the 3 and the 2. Now this one, the square, 2xy. You don't even need the dot there. Can you just, yes, I changed that to a 3. You can just write this like this. Now, if you wrote it out, you could see that you need to distribute your exponent into every single term. Because let me write it out. 2xy times 2xy. Multiplication. You can multiply anything in any order. You get 4x squared y squared. That is like me making sure every single term is being squared. So that's another rule that you can remember, or you could just kind of understand conceptually that yes, you're going to be multiplying everything by itself however many times. So do this one. 4y squared times x cubed cubed. I missed some. Okay, we're right here. It would be 4 cubed. Y to the 6th. x to the 9th. How do I know that? I can think about writing it out. 4y squared x cubed times 4y squared x cubed times 4y squared x cubed. What's 4 cubed? 4 times 4 is 16 times 4 is what? 64? Okay, so I got 64 y to the 6th, x to the 9th. Okay, now we're going to combine a couple of our guys. We have powers to powers, and we're multiplying. Let's start with this one. This is a tricky one. You can either work inside out and say, okay, this is 5 to the 6th, y to the 6th, to the 0, or you could have just gone outside in and just known your answer right away. What is anything to the 0 power? 1. So this is just 1. Okay, try this one out. Everybody get an answer to this. Check your answer to the neighbor.
Wait,
Yes.
wouldn't it be 5y?
No, because it's 5 to the 6th to the 0, which is 1. And then y to the 6th to the 0, which is 1. Anything to the 0 power is 1. So that one's tricky. Let's try this one. Yeah.
You had that. Could you add those together or what?
Well, do you see any plus signs?
No.
No. So you could put a dot there in between the 4 and the x to the 8. You could put a dot there between the 5 and the x to the 5th. And you understand that you can multiply anything in any order. But the one thing I'm concerned about is your 2 to the 4th being 4.
Oh.
Check your answers to the neighbor. Some of us are forgetting that you're taking 2x squared 4 times. So I got 2x squared, another 2x squared, another 2x squared, another 2x squared. So I got 2, 2, 2, and 2.
That's a 13, not a B.
What is with the triangles? Similar guys?
So you put them together.
Okay, and that's a 13? Okay. All right. This is 2x to the 4th 4 times. I'm going to write it out just so you can see it. Sorry, 2x squared 4 times. 2x squared, 2x squared, 2x squared, 2x squared. Now, multiplication, there are dots between all of these, okay? Which means you can multiply all of the 2's that you want, which means you have the 2 to the 4th, which is 8. 2, 4, 8, 16. 16. You have x squared 4 times. X squared, x squared, x squared, x squared. You're multiplying that. That's 8 x's. And then you have 5x to the 5th, separated by 1 dot. But the dots exist everywhere. This is all multiplication. And multiplication is beautiful. You can multiply anything in any order. Okay? So I can multiply this 16 and this 5. What do I get? 80. And I can multiply these 8x's with these 5x's. And do I get 40x's? You just add, you just get 13. Okay? Yes. No. You already went to the bathroom. Let's skip this one because it's got some negative exponents. Go here. Don't take 3 to the 4th or negative 3 to the 4th. Just write it out as like 3 to the 4th. So that you don't have a ginormous number. Because I know negative 3 to the fourth will give us a positive number. Negative 3 to the fourth is the same as positive 3 to the fourth. I can simplify those 3 to the fourth to be 3 to the eighth. All right, now I have like a bunch of parentheses, more parentheses. See if we can figure this one out. Sometimes it's best to just get rid of those parentheses. But I got to figure this out. Go ahead and do it. It's easy to write down these answers. You have to be able to do it yourselves. Go. Yes, yeah. I don't know. Question. The last one we just did? Yeah.
How did you get 3 to the 8?
Because negative 3 to the fourth is the same as 3 to the fourth, I turn this to a positive 3 to the fourth, which means I have 3 to the 8th. So I just turned this to a positive. And I got 3 to the fourth and 3 to the fourth, 3 to the 8th.
Wouldn't we do 3 times 3? Like to combine them?
Well, I mean, would I? 3 to the fourth is 3, 3, 3, 3. And then 3 to the fourth is 3, 3, 3, 3. Is that the same as 9 to the fourth? It doesn't look like it. It looks like it's just 8 3s being multiplied together. This is tricky. What should I do first? I should square the 2w squared to give me 4w to the fourth. If you are unsure of what to do, you can write it out. You have 6 5w's, 2 2v's, and then I have 2w squared twice. 2ww, 2ww. This should confirm that you have 4w to the fourth on the right side. You still have 2v squared, and you still have 6w to the fifth. But things can be in any order, can be done at any time with multiplication. I have 9 w's being multiplied. I have 2 v's. I have 6 times 2 times 4. That's 8 times 6. That's 48. Anybody get 48 w to the 9th v squared? Good. If you did, great. If you didn't, it's because you're probably not trying. You have to try. And if you're trying to get the easy way and you're not sure of what you're doing, yeah, you're not going to get it right. When in doubt, write it out. Next guy. 2m squared. 4m to the fourth. I can write this out. 8 squared is 64n squared. I can do 64 times 4 times 2. 8 times 64. 512. I have 6 m's, 2 n's. Okay? Next page. Somebody tell me, what is x over x? Just 1, right? That guy can go with that guy, and I just get 1. Now what happens if I have 1x and 2 x's? Do I cancel all the x's? Cancel, cancel, cancel? Let's see. I don't know. Maybe this is 1, maybe this isn't. Let's try with a number. 3 over 3 times 3. That's 3 ninths. 3 ninths. Okay? Is 3 ninths the same as 1? No. What is it the same as? 1/3. I can cancel one of those x's with one of those x's. We can do, almost think about this as x over x times 1 over x. And I know this is 1. I'm left with that. So if I have x squared over x to the 5th, and I'm not sure of the rule, I think it has something to do with subtraction. I can write out x times x over x 5 times. Well, I got an x over x. That takes care of this one and this one. I got an x over x. That takes care of that one and that one. And then I have just a 1 and then 3 x's left over. This is 1. This is 1. How much do I end up with? 3 x's in a denominator. Do I end up subtracting the 5 and the 2? Yeah. But do I have like x to the negative 3rd? No, I wrote it as like 2 of these x's cancel with 2 of these x's, leaving me with 3 x's left over in the denominator. Okay? That's the introduction to division of exponents. Now we're going to do everything all at once. Look, a to the negative 5th, b to the 3rd, ab to the 4th. First thing I got to do, maybe take care of this ab to the 4th. I know that's ab, 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 ab. That's 4 a's, 4 b's. So I got this a to the negative 5th, I still got this b cubed. And now this is where students think, oh man, we got a division. I need to subtract. But I don't want to subtract yet because I still got a negative exponent. Get rid of your negative exponent. This is a great example. I get b cubed, b to the 4th, a to the 5th, a to the 4th. This is where if you're stuck in rule mode, you might be confused. But if you think conceptually, okay, I got 3 b's, I got 4 b's, and in the denominator I got 5 a's and 4 a's. Well, in the denominator, the 5 a's and the 4 a's can combine to be 9 a's. And then I got 3 of these b's that cancel with 3 of these b's, leaving me with 1 of these b's in the denominator, which means I got nothing in the numerator at the end. The next guy, if you ever see a power to a power, fix that first. P to the negative 5 q cubed. I'm going to say, now this is tricky. There's 2 ways to do this. You can either kind of distribute in this negative 3 into both of them, or you can move all of this up. It's up to you. Let's just say we distribute it in like that. Well, now I'm going to move stuff around. I got p to the 6th, the q cubed stays. I have another q cubed coming up, and I have a p to the 5th moving down. Yeah.
And on that one, I have the 1 over a9 p3.
Yeah.
Why is it p3? Why does it be like p by itself?
Oh, I don't know why I put b3. Thank you for recognizing that. I probably said b to the 1st and messed up. Here, 3 cubed, 3 cubed, 6 cubed. 6 of these p's cancel with 5 of these p's, leaving me with 1 p in the numerator. These, my friends, are exponent rules. Okay? We have more that we will do for practice for next class. Okay? But this is it. So we'll finish your notes for practice. You should practice your own, redo the notes, or do the homework problems. These can be tricky.